All right, so now we're recording. So I have a watermarked version of your picture. All right. I've forgotten who it was that Mia, came by yesterday, and I didn't realize until she told me that I really had not done the first graph correctly. I'd left out like the 4 when I did the example. So we're going to do graph number 1 also. And if you copied what I did off of the video for your number 1, I think it was wrong. I don't think I took into account. I maybe copied it down wrong, or I'm sick and crazy. I don't know. Okay. What does number 1 actually say?
Negative 4 sign, parentheses 4x minus 5 plus 3 plus 3.
I think the other day I actually graphed this one without the 4 right there. So this is what it needs to look like on test day, okay? First of all, let's say this, real important. Okay, this you're used to, okay? You're used to graphing like that from 0, 0. So now all I'm asking you to do is graph that from like somewhere else, okay? That's it. All right, so let's do it. I'm redoing number 1, Dakota, because I don't think that I did the right equation the other day at the end of class. Okay. So look at your number 1. If you need to correct it, do that. The amplitude is 4. The period is 2 pi over 4, or pi over 2. The count
Pi over 8.
is pi over 8. And up until now, you were finished, because all this stuff wasn't here. And you would just go pi over 8, 2 pi over 8, and so on. But now it's shifted over and up. And so to find your phase shift, set 4x minus pi equal to 0. And are y'all okay if I just do it in my head? Yeah. If you could read that writing over there. I added pi and divided by 4. So I get pi over 4. That's his phase shift. Trying. Pi over 4. And what's the vertical translation? 3. So I have a graph that you already knew how to do. And it's going to move right and up. Okay? All right, so let's do that. Now I'm going to go slower because it was flying at the end of last class to try to get one of these shifted ones in. Don't forget your question, but I'm going to keep talking. You do have to plan ahead for your graph to be drawn to scale, okay? So if Nazareth, you'll do this first. You'll find your target first, what you're going to count from. If Nazareth goes and goes, this is pi over 4, that's great with me as long as she's consistent, okay? If Alex goes, this is pi over 4, that's fine with me as long as she's consistent with her size of her mark. But isn't that true anyway? Where in the past, if Kate had gone 1, 2, all of a sudden she wouldn't start going 3, 4, 5, 6. Okay? But if Anya had gone 1, 2, I don't mind, that's okay. Do y'all see how once you've made your decision to the person reading your graph, you've got to be consistent. The reason that I'm so adamant about that is, girls, if you're going to draw a graph for somebody, it needs to be correct. Because when you're an adult, and it's hardly going to happen to you some, if you have like medical issues or something. When I took my kids to the pediatrician would sit there with a laptop in his lap, and he would turn it around and show me a graph of something. When I, broke my wrist, they're like, oh, hey, look at the x-ray, and it had like markings on it and numbers and everything. When I get my measly 401k investment report in the mail every quarter, it has a graph on it, okay? Now, I don't want it to go January, February, March, April, May. I'm gonna go, who is doing my investments? That's crazy, okay? I also don't want this. We'll pretend like I have $1 million. You know, like in January, you had $1 million. And in February, you had $2 million. Heck no. I really want to see that happen, right? Okay? Did y'all see what I mean?
Yeah.
All right? Now, once you decide on a scale, you have to stick with it. So actually, if one of my investments, like suppose that a long time ago that maybe my stockbroker had advised me to invest in Apple or Google or Amazon or whatever 20 years ago, okay? I would have gone, yeah, okay, I'll do that. It's moderately risky. I'll buy some stock, which I didn't, which I wish I had. Because if I had bought a few shares of stock, do you see they'd have to readjust my scale probably? What used to might be $100,000, $200,000, $300,000 for some people, it went crazy, and they were lucky enough to have done that. And so, do you see? Then they might have to adjust my scale. Medical graphs, financial graphs, investment graphs, sales graphs, revenue graphs. Your parents are looking at graphs all day long. Okay? In fact, when I don't really feel like reading an article, I'll look at the graph. And it pretty much tells me what I need to know. Okay? But the graph better be done right. So that's why I'm so adamant about it. Also, I don't want this. Why am I making you label everything? You don't give somebody a graph and they're not having any idea what happened in March. Something good happened in March, but I don't know how much money I have. Do you see all of that really is important? So I'm going to talk about that a little bit slower now as an expectation by the time we have a quiz or a test. All right, so here we go. All right, so always this is your new starting place. That's your new 0, 0. That's where you're going to start from. And that's just a Lazari thing where I put a little X there. It's your target. All right, so this is pi over 4. And I'm going to go up 3. All right, and I may decide, there's times I've had to redraw them. Like I didn't like my scale because I had to go like off the board. So I might go back and make pi over 4 a little smaller sometimes. Okay. What's the relationship in pi over 8 now when I start counting by it? How big is pi over 8 in relationship to pi over 4?
Smaller,
it's half of it. So it's just like if you've gone out to, Brent, I know you have a question. If you've gone out to 1 and then you're going to count by halves, that needs to be smaller. So I need to see that. So from this target, I'm going to count out 1, 2, 3, 4. I tried to make those kind of half as big. So I'm going to count out 1, 2, 3, 4 from my new starting place. So I'm going to label them on the axis. I'm going to make my phase shift 2 pi over 8. That's all you got to do. The rest of it falls pretty easily. Pi over 8 plus 2 pi over 8 is 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8. Is that 3 pi over 2? 6 pi over 8. 3 pi over 4. You don't have to reduce those. As long as they're the correct numbers, it's fine with me. Now, just for argument, just so you see this, what period of time have you marked off on your axis? How far is it from 1 pi over 4 to 3 pi's over 4? Isn't it 2 pi over 4? From 1 to 3? And 2 pi over 4 has a chunk of time that's a period of pi over 2. So what we're doing now is really more realistic. If I'm talking about World War II, I might say it lasted however many years. But do you see that it's somewhere along this number line, during that period of time, there was a war. Then there was World War I, another chunk of time. The Vietnam War was at another chunk of time, another period of time. So it doesn't have to start at 0, 0. Probably doesn't. All right, so now, Brian, what's your question?
How did you get pi over 4?
I always set this equal to 0 to find out where it shifted over.
Alright, cause what if,
Phase shift.
alright, cause I thought that we had to start at pi because it said minus pi. So if you have to like shift
Okay,
it over
hang on,
1 by
Brent.
pi.
When I started, I said I didn't do number 1 correctly because I didn't realize it had a 4 right here. But when Mia came by yesterday, I realized that, so I'm redoing number 1.
Alright,
The one I did in class the other day just said x minus pi. It didn't say 4x minus pi.
oh, alright.
Great question though. Let's look at this before I go in and finish this. I'm always on my.
I didn't realize that the four made a difference for shifting.
So let's look at that. All right. So let's make a parent graph. All right. I could square it. I could cube it. I could take the sine of it. Girl, as soon as I square it, you're gonna see a u. As soon as I put absolute value on it, you're gonna see a v. As soon as I put sine in front of it, you're gonna see a wave. Do y'all see all those parent graphs? So let's square it, because it's easy to talk about. All right, let's look at what Bren's saying. All right, as soon as I square this, where is that red parabola gonna go? It's gonna go back to Bren, okay? Now let's look at this. By the way, the reason for that is, fill in -2, girls. What's -2 plus 2?
0.
Do you see it tells you your new 0? Okay. As soon as I square this one's not going to go to the right 12. See what Bren was saying, which is a very common thought, is it's just going to shove right 12. Where'd it go? It went right 4, okay? Because what's happening in here, this is called the argument. The 3 is impacting it along with the 12. But if you check and see what makes that 0, what makes that 0? 3x minus 12, it'll tell you where to move it. So some teachers teach it like this, which I don't. But in case you see it, maybe Miss Arcan's student do it this way, or video might do it this way. Do you see that the green and the purple are the same graph? So some teachers teach you to factor out the 3. All right? And then look at how far it's moved. I basically am doing the same thing, but making it easier on you. Okay? You are kind of factoring out the 3 when you add 12, and then what do? Divide by 3. So it's a whole lot easier just to always set that equal to 0. It'll tell you where it goes. All right? Hang on just a second. Did y'all see the 3 also stretched the graph?
Yeah.
Vertical stretch. But it moved over a composite of 4. So, Bren, these two numbers interact together. Okay?
Thank you.
Really good question, but it's hard to understand why unless you see it.
Yeah.
Now, what I thought had happened on number 1, I think I worked it the other day, as x minus 4, x minus pi, not 4x minus pi. So that would be confusing also. Anya?
I was just gonna ask, but you answered it. Is the reason why the green graph was so much skinnier than the other graphs because the 3 was touching the x?
It was a vertical
Yeah.
stretch, which, by the way, doesn't always make it skinnier. So it's a stretch. Like, for instance, if my parent graph was this, so I made it fatter, okay? But I'd rather you say vertical stretch.
Okay, so vertical stretch.
So if you stretch something, some things get wider, some things get skinnier. So we can't say that.
Okay.
Okay? So it's a vertical stretch or shrink. All right?
To get the numbers along the bottom, did you just add the phase shift to the count? Like add the count to the phase shift?
You always do that.
Okay.
Let's look at that.
And how do you know when it ends?
Okay, this is what you need to do. Find your amplitude, period, count, which you've been doing anyway. But up until now, your phase shift and your vertical translation, up until the last few minutes of the last class, were always 0, 0. Because there wasn't anything added or subtracted. Okay? So this is your new 0, 0. start counting from this. Okay? And so you used to have 0, and you count out 1, 2, 3, 4. So now you're going to start at your phase shift. You're still going to always count out 1, 2, 3, 4. Because these graphs are going to go high, middle, low. Sorry, I did that wrong. Oh, that was extreme. Okay. So you have a place to start, high, middle, low, middle, or high, middle, low, middle, back.
Yeah.
They're always divided up into nice 4 equal parts. Up until now, you just started at 0 and counted out 1, 2, 3, 4. So how do you know when to stop? I have you divide it into 4 equal parts, always.
Okay.
So go to your phase shift and count out 1, 2, 3, 4. All right, now let me get some done. Because I think if I clock through some instead of spend 15 minutes on one problem, you'll get a better picture, okay, of what's going on. You'll get a consistency. So we got kind of off the topic here on some good questions. But I found all my things. I want to go put my X, the Lazari X right there, okay? I just think it's good to actually look at it. And then you're going to start counting by pi over 8s. And so I went out Kate 1, 2, 3, 4, okay? And then I look and see what kind of graph I have. If it helps, this is like your new quote axis. It's actually called translation of the axes. It means there's really not an axis at 0, 0. You can have your axis anywhere you want it. I just moved your axis up here. So look at that. You see what I mean?
So it would be 4 up.
I'm gonna do it. Okay. Slow down. Okay. So I see that it's a sine graph, which means I put my dot right here. Okay. At the 0, at my new 0, 0. All right, I see that it's negative. So on this mark, I'm going to go down 4, go back to the middle, then I'm going to go up 1, 2, 3, 4, and then my last dot should be back to the middle. Now, by test time, I require that you graph 2 periods. And so, which way do you think I should go?
Back down.
I think I would go back that way. It makes kind of more sense. You see what I mean? You could keep going that way, but be careful. If you go back that way and you didn't leave enough room, you may have to redraw it because I demand it's drawn to scale. All right, I was at pi over 4, which is 2 pi over 8, and now I'm going backwards. So I'm going to subtract pi over 8, subtract pi over 8, and I have another one that comes like this. Next point's down, up, high, down. And the average or the, oh, whoa, that's wrong. I wonder if it's gonna undo the whole thing.
Probably.
Don't make a W. This one was coming from down. I should have gone up, down, and then down, and then back up. So it should have looked like this. Okay? Now, could I have written that equation a little bit easier?
Maybe.
It's exactly like this equation.
Maybe.
That's oh, I'm sorry, not quite.
Did you have pi?
If I type in the black equation and the red equation, I will get the exact same picture. I'm going to tell you. What did the pi do? If I say minus pi, what effect does that have on the graph?
It moves it right or
Good, it moves it right or left. And not just pi, because we know that we got to include the 4, but it moves it, okay? Do y'all see a sine wave right here in purple? y'all see a sine wave right there?
Yeah.
Oh, what kind of sine wave? Positive or negative? Positive. So I just thought, you know what? If you asked me to write the equation for that picture, I would have done the red graph. Do you see that I have a sine wave that's moved up 3, but there's not even shifted over?
Oh, yeah, because it doesn't matter because it's continuous.
Yeah. Did y'all see it? Yes. Yeah. So technically, how many equations could you write for the same graph?
Infinite.
An awful lot. Some of them make more sense than others. But Dakota's right. I could go 4x minus and think it's going to shift way down here or way over there. But it'll catch up with itself.
I really want to do the y equals mx plus b to it, but I don't think that works.
You want to what?
Like do the y equals mx plus b. You know?
Like a line?
That's
You
linear.
just make a line.
That's linear.
Yeah,
Like a straight line.
That wouldn't make anything wavy for us. Yeah. You know, it's very similar though. Kate, the M was telling your slope,
Yeah.
and the B was telling your y-intercept. You needed those 2 key things.
Yeah.
Lines are just so much easier, so we need more on this.
Mine's already easier.
But it's like you're kind of getting more stuff about that picture.
Yeah.
Okay?
Feels like it's
I just have a question. So if it doesn't really change it if we have the pi there or not, then I mean, wouldn't it actually
did change it.
at some? Or because I'm just thinking out of curiosity.
Well, look, Dakota, I made this positive 4.
Yeah. No, because I was thinking of, so this, if it was like that, that's just how the graph is, but then if it was moved over here, again, like that's the same graph, right? But what if it was moved over to like right here, it would be like a different, it would be like not.
Oh, there's an infinite number, but there's a lot that would be wrong. There are an infinite number. You would have to write ones that actually shifted onto
Okay,
the
I see.
picture you have.
Oh, that means
You couldn't just like start adding and subtracting because you might not shift it to the right place. You would have to add and subtract the right numbers. Dakota and I are the only ones that's going to do trigonometry. All right. Thank you, Dakota.
Yeah,
in the middle of Spanish class and our teacher judged.
This is very like the way Julia claps.
I don't clap that way. Anya makes me.
Just do it.
Dakota can do it too.
I couldn't do that. I can't snap either. All right. So
I jammed myself, not like officially.
let me just pause and say 2 things.
Okay.
I got things we got to get through today, okay? And I like to have fun as much as anybody else, maybe more so. I'm usually more distracting than you are. The second thing I want to say is the perception of the people from the outside world of when I was going to move to New York and teach at this fancy school, this castle on Fifth Avenue. In their mind, did they not? I don't think they imagined this. I'm trying to teach about phase shift, and it's just so delightful. They just had no idea that's going on. Yeah. All right. I didn't realize that was going to happen. All right. Number 2. Will you read that to me, Ava?
Yes, y equals 2 plus 4 cosine, parentheses, 2x minus 5.
All right. I'm going to clock through this one. I'm not even going to take questions until I'm finished. Okay? Amplitude 4. Period 2 pi over 2 or pi. From wherever I'm going to count by, I'm going to count by pi over 4s. Phase shift. Now that we talked about it, set that whole thing equal to 0, you'll get pi over 2. Vertical translation is the number added to the front or the back is 2. This is your new starting place. You will add to this. I think everyone on this page either shifted to the right or not at all. We'll have some that also shift to the left, okay? All right, so I'm going to go to pi over 2. And I'm going to count forward 1, 2, 3, 4. All right, so I'm going to change my starting place to 2 pi over 4 so that I can add pi over 4. So I'm starting at pi over 2 and adding pi over 4. So when I say 2 pi over 4 plus pi over 4, I get 3 pi over 4, 4 pi over 4, 5 pi over 4, and 6 pi over 4. Sorry, it doesn't write very good over there. I'm going to put my target at pi over 2, 2. if it's a sine graph, I'm going to start right here on my target. Well, I'm dot right there on my new oranges. But it's not a sine graph. It's a cosine graph. And it's a positive cosine graph. So I'm going to start up high above my new midline.
Anywhere like
Okay? So I'm going to go up 1, 2, 3, 4. It's going to go high. Then I'm going to go down 1, 2, 3, 4. So it goes high, middle, low, middle, high. And then I want you to graph through 2 periods. So I'm going to count backwards now by pi over 4s. This was 2 pi over 4. So now I'm going to go backwards by pi over 4s. Negative pi over 4, 0. I'm sorry, that's positive pi over 4. 2 pi over 4 minus pi over 4 is pi over 4. Pi over 4 minus pi over 4 is 0. Negative pi over 4, negative 2 pi over 4. So now it's going to come back to the middle. Then it's going to go down low. It's going to come back to the middle. And then it's going to end up high. And you're going to make it really curvy. Okay? All right, any questions on number 2? All right, Kate?
Why is the period pi instead of pi over 2?
To get the period, you say 2 pi over. 2 pi over, 2 pi over. This is like your old equations.
Yeah.
I now have a phase shift and a vertical translation.
Yeah.
But that's the heart of my graph.
Okay.
Period's 2 pi over 2.
Okay. And then the okay.
Okay, Anya?
When you
Sorry.
have to extend it and like make it 2 periods, can you also go forward instead of going back?
You can, it doesn't make a whole lot of sense, but you
Okay.
can. I mean, yeah, it as long as you just graph 2 periods, you can keep going forwards. All right, number 3, Nazareth, what does 3 say?
5 cosine 3x minus pi
Plus 4?
4. Yeah.
All right, so the amplitude is 5. The period is 2 pi over 3. The count is 1/4 of that, which gives me pi over 6. My phase shift is pi over 3. And my vertical translation is 4. I'm sorry on the first ones I gave, I keep going right and up, but they could go back and up, back and down, right and down, whatever, okay? All right, so this is your new starting place. I keep circling it. You're gonna always add to that number. So I'm gonna change this to 2 pi over 6 instead of pi over 3. So I'm gonna call this pi over 3, which is 2 pi over 6. Plus pi over 6 is 3 pi over 6, 4 pi over 6, 5 pi over 6, and 6 pi over 6. My target is at pi over 3, 1, 2, 3, 4. From there, my new midline, I'm going to go up 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5. If it was cosine, if it was sine, I would put my first dot right there. But it's cosine. It's a positive cosine. So I'm going to put my first dot up 5. Then I'm going to come down, low, middle, up. Okay? And then when I count backwards, I'd have to be really careful. Because when I say 2 pi over 6 minus pi over 6, that gives me a pi over 6 in here that I kind of have to squeeze in a little bit. I didn't draw it very well to scale. It continues on like this. Middle, low, middle, high. And I can't believe I'm going to do this while y'all are being really quiet, but this reminds me of I can't believe I'm doing this.
Oh my gosh,
Oh,
reindeer.
You know reindeers are
Oh.
No.
Yeah.
Okay.
What did she say?
Reindeers are going extinct.
Reindeers are going extinct.
All right, Alex, number 4.
Number 4 is y equals 2 minus 5 cos. And then I believe you changed it to 4x to plus pi. That's in parentheses.
Was this the one that had the -3 hanging off of it?
No.
Or-
No. So then no.
Oh,
So then it's
So-
2x plus pi then.
It's
And
2x plus
Instead of the 4.
I'm confused.
Yeah, wait, where'd you get 4x?
I don't know. I thought that we were supposed
She
to like.
emailed us.
Yeah. Whatever you emailed us, I thought I applied to that question. So
Oh,
I changed
okay.
it to 4.
Sorry. I just sort of try to adjust. Are you okay so far?
I'm okay.
Okay. All right, if you want me to check yours later, I'll be glad to.
Okay.
All right, so the amplitude is 5, the number multiplied to cosine. The period is 2 pi over 2. The count is pi over 4. Phase shift is negative pi over 2. Oh, was it 2x plus pi?
It's 2x plus pi.
Okay, so this is negative pi over 2, so it'll go back. And the vertical translation is 2. This is my new starting place. I'm going to make this negative 2 pi over 4, so I can add in a minute. All right, so I'm going back pi over 2 and up 2. That's my new target. Here's my new midline, okay? All right, now I'm going to count by pi over 4s. So if I say negative 2 pi over 4 plus pi over 4, I get negative pi over 4. Plus pi over 4, I get 0. Sorry, kind of cut off there. Pi over 4 and 2 pi over 4. How far is it from negative pi over 2 all the way to positive pi over 2? If you go half a pi one way and half a pi the other way.
0.
No, this distance is definitely not 0.
Oh, pi.
That's pi, isn't it? If I go back half and forward half, should the period be pi? All right, now, this is cosine. So my dot does not start there. It starts at negative 5 below that. So we'll start down here, and we've got to mark off our units. Okay? So low, back to your midline, high, back to your midline, and then low. And for our purposes today, I'm only graphing one period. Okay? But you should do more. Because I don't want you to think that's what it looks like. I want you to really see that's what it looks like. Let's get back to something Dakota brought up earlier that we were talking about while you were waving your hands in the air. What engineers do when they actually see a wave coming on a machine, or they're trying to emulate, model something with an equation, is they really, Dakota might graph that as a negative cosine from right here, okay? Bryn might see it as a positive cosine from the center. You could also do it as a sine wave if you wanted to. So as Dakota noticed a little while ago, there's an infinite number of ways to write this, but I also could either write it with a sine or a cosine. Couldn't I probably write an equation that would make this happen? I could write a sine wave that shifts back pi over 4. Okay? All right. Number 5. Kate, what's number 5?
Y equals 5 cos pi x minus 7.
No.
Cos.
Cos 5 cos, sorry, 5 cos pi over x. No, pi x.
Is that it?
Minus 7.
No. Minus 7.
That was difficult. Okay. Amplitude. 5. Period is 2 pi over what? Pi. Just,
Oh, that's not right.
yeah, and if you saw your sheet, you'd see it better. Sorry, I'm not writing
No,
very
it's
clearly.
y equals 5. Wait, no, never mind.
It's
Sorry.
5 cosine
Yeah,
pi
you're right.
x minus 7. Girls, pi is just a number. 3.14 You can divide by it. That's the coefficient of x, okay? So it's 2 pi over pi.
Which makes it 2.
So the period's just 2, the integer. You're going to divide that by 4 and count by halves. Phase shift. What happens if you set that equal to 0?
You would get pi.
The phase shift is 0.
0.
Pi x equals 0. Divide by pi, you just get x is 0. But can you see there's no phase shift? Nothing's added in the parentheses. The vertical translation shifts it down 7. So I'm going to start at 0 and count by halves. 1, 2, 3, 4. I'm going to go down 7. And there's my midline. Then I have to go 5 below that. Okay. Now, was this a cosine?
Yeah.
Positive cosine. All right, so here's my target, 0, negative 7. So I'm going to do 5 cosine. I'm going to start up 1, 2. Cosine, middle, down 5, back up, again. Back to some old words. Domain and range. The domain of sine and cosine is all real numbers, okay? The range of this, do y'all remember doing range like this? Your range is just going from like negative 12 to 2. The numbers are going to stay right in there,
So it's just the highest and
okay?
like the x value, I mean
Yeah.
y value, sorry.
Your range is just from bottom to top. All right, now let me show you how to graph secant and cosecant, okay? But you should justifiably go, time out. We got 4 minutes. Not that you don't do that to us all the time, but time out. You're about to show us how to graph secant and cosecant. Girls, it's that easy, okay? So watch. All right, so let me get rid of these. All right, so if I graph 3 sine x minus pi plus 2, okay? Did everybody see that?
Yeah.
Now I'm going to graph 3, what's the reciprocal of sine? Cosecant x minus pi plus 2.
Oh, what?
What?
Oh, I love that.
Okay,
Wait, I'm so confused.
I'm going to show you. Okay,
That's my favorite.
girls, shh. We need to use our last few minutes very wisely, okay? So what's happening is this. When on your homework, you've got to graph. Let's say if I say, did I ask you to graph y equals 4 cosecant 3x minus pi minus 2. Okay? Don't graph cosecant. Graph sine first. Think about this with me. If I ask you for cosecant of pi over 4, you don't find that. You find sine of pi over 4, and then you flip it over. So just ignore my instructions at first and graph its reciprocal. Because what Bryn immediately noticed, even before I did it, she said it was going to flip over. They're reciprocals of each other, okay? So the amplitude of this is 4. The period is 2 pi over 3. The count, if I'm in a hurry, is going to be pi over 6. Is that right? Yeah. The phase shift is pi over 3. And the vertical translation is negative 2. So I'm going to go right pi over 3 and down 2. And here's my new light target. Okay? And then I'm going to draw a sine wave. But I'm only going to dot it in because I'm not really supposed to be drawing a sine wave. So I'm gonna use it as my model, okay? So I'm gonna go up 1, 2, 3, 4, and down 1, 2, 3, 4. I'm not gonna, in interest of time right now, I'm just gonna count out 4, but you would label them like I taught you today, okay? It's sine, so I start right on the target. It's positive, so I go up 4, come back to the middle, go down 4, come back to the middle. And that's my model, okay? Now, this is a good time to have more of them. That's one reason I want you graphing through 2 periods, because it's going like that, okay? Now, look at this. Here's a normal sine wave, the first one you ever saw, okay? What's the reciprocal of 0? Undefined. So everywhere it hits the midline, your cosecant graph will be undefined. What's the reciprocal of 1? 1. What's the reciprocal of 1/2? 2. What's the reciprocal of 1/2?
2.
So do you see how these little U shapes, they meet right there.
So it wouldn't
But
be
then
like,
they flip over because while one's getting smaller, what will its reciprocals be doing? Getting bigger, okay? So, this is all I have to do to finish it. Do like last night's homework, and then for cosecant, your graph will go like this. Every midline is an asymptote. Every time it hits the midline, you have an asymptote, okay? Then hit your top of your amplitude and turn your U shape up. Hit the bottom of your amplitude and turn them down. So the positive U shapes will go like this, and the negative U shapes will go like that. I'll give you a few to try for whenever I see you again. Okay? So I'll put some pretty good detail in assignments. It'll probably say for Friday and Tuesday or something so that you know to look at it. Bye, girls.